demo we're going to do today involves air pressure. And air is constantly around us, even to the point where we may not always notice it. We did talk earlier in the year that air has mass. Anything that has mass also has a weight. Because air has weight, it's constantly exerting a pressure on us, or a force. And the current air pressure is about 718 millimeters of mercury, which comes out to roughly 13.9 psi. And psi is pounds per square inch. I have a 1-inch square piece of paper taped to me right now labeled with 14. In this 1 square inch of paper, I'm experiencing about 14 pounds of pressure. 14 pounds isn't an insignificant amount of pressure. So why don't we notice it? Well, our bodies are calibrated for this pressure. We're born, we live our entire lives at approximately the same air pressure. And you may notice some changes in air pressure if you've ever traveled. For example, if you go from a high elevation to a low elevation, you may notice a difference in air pressure because your ears will pop, or if you've ever traveled in a plane. Another form of pressure you might experience is water pressure if you've ever been swimming. If you go below the surface of the water, the pressure tends to build up much quicker as you go deep into the water. You'll notice as you get further and further down in the water, the more it's pushing, and you notice specifically in your ears. Your ears are the place where you tend to notice the pressure the most because it's the most sensitive to pressure. Sound is very small changes in pressure traveling through, in most cases, the air. So your ears are very sensitive to those light changes in pressure which come from sound. The demo we're going to do today involves a trash bag. And this trash bag, being surrounded by air, experiences the same 14 pounds per square inch that I'm experiencing. So why isn't the trash bag being crushed? The reason for that is the inside of the trash bag is also filled with air. So the outside is experiencing 14 pounds per square inch trying to crush it, and the inside is experiencing 14 pounds per square inch pushing outwards. So all of those pressures end up canceling. We're then going to take a shop vac and we're going to suck some of the air out. And by sucking some of the air out, we're actually reducing the amount of pressure on the inside. We're doing that by decreasing the amount of air. With a shop vac, we won't be able to decrease the air pressure inside very much, but even if we were to decrease it by 1 psi over the very large surface area of the trash bag, that's going to translate into a very, very large force very quickly. And that force will be demonstrated using my brother Kyle. Kyle will be in the trash bag when we suck some of the air out, and that trash bag is going to get squeezed in by the air pressure on the outside, and the large surface area, even if we only decrease the pressure inside by 1 pound, that's 1 pound on every square inch on the outside. So that's going to create a very large force and make it very difficult for Kyle to move. A couple quick safety notes for this demo. I don't recommend trying this at home. And one thing you should never, ever, ever do is stick your head in the trash bag if this demo is being done. You really don't want to put your head in a sealed container where you're taking the air out of. It's not a good recipe. Another safety note, I'm going to stay within reach of the on-off switch, and I'm going to be constantly checking on my brother to make sure that he is okay throughout. If at any point I feel we're unsafe, I'll stop the vacuum cleaner and get Kyle out of the trash bag. Alright, I've got Kyle down into the trash bag. I'm going to hand him the hose on the shop vac here. He's going to make sure that nothing can get into the hose and plug it up so we don't burn the shop vac up. I'm going to go ahead and hand that to him. And we're going to try and seal the bag around him as best we can. And we're going to turn the shop vac on. Okay, so I've got the shop vac turned off. I'm going to release the seal. You should notice as the air comes back in, he can then move easily again. Describe what you noticed while you were in the bag before the vacuum cleaner was turned on and then after the vacuum cleaner was turned on.
Or before the vacuum cleaner was turned on, it wasn't constricting. It was just like a loose-fitting t-shirt. It was just like wearing a poncho really. And then once the vacuum was turned on, there was a lot of pressure. It just felt like you couldn't move. It was very constricting, and there wasn't really any way to move while there was a seal on the vacuum, on the bag of the vacuum.
Okay, thank you. I hope you guys enjoyed that quick demo involving air pressure. I hope it teaches you a little bit about the world around us. I hope you guys are all safe at home. I know this isn't an ideal situation to try and learn chemistry and learn about the world, but we have to make do with the best we can in these uncertain times. I'm still holding out hope that we'll get to come back, if even for a short amount of time, to see you guys at the end of the year. Again, I hope you're all well. Good luck, and if you have questions, as always, email me, post them on Teams, reach out. I'm always willing to help.